Saxon's Trig, Lesson 25, Age Problems and Rate Problems, beginning on page 178. These are word problems, and again, we are going to break them down piece by piece so that there is no frustration as you do them, we hope. So example 1 says, 10 years ago, Thomas, so I'm going to use a T for Thomas, and the only thing that's unique here is that when it says Thomas 10 years ago, it is implying that same 10 years ago for whoever else is in the problem. So Thomas was twice as old as Patricia. So I'm going to go ahead and do the 10 years ago, because if he's 20 now, we're talking 10 years ago when he would have been 10. And that's a unit stuck together, parenthesis. He is twice as old as Patricia. So I know I have a Patricia and I know I have an equal. Now again, as we learned the last time we were balancing word problems, which one is bigger is the question I asked. So that was Thomas is twice as old. So I need to put the 2 with Patricia multiplying in order to keep it in balance. And I said it is implying Patricia 10 years ago. So I also need that in a unit with Patricia. Continuing, 10 years ago, Thomas was twice as old as Patricia. 5 years from now, Thomas will be, so that's a unit, adding 5. He will be 10 years older than Patricia. So who is older? Thomas. So I'm going to add the 10 to Patricia's side, and I know her unit also has an implied plus 5. So again, I'm reading, Thomas will be 10 years older than Patricia. How old are both people now? So these are the 2 equations with 2 unknowns that are set up. We need to simplify as much as we can and then either substitute or eliminate. So Thomas minus 10, I don't need the parenthesis to remind me anymore it's a unit, but we're going to move stuff around. 2 times P and 2 times negative 10, negative 20. Same here, T plus 5 equals, and again, this one does not need to distribute. I'm going to look for combining my like terms. 10 plus 5 is 15 plus the P. So I've got more numbers here. I could solve for the T here, or I could solve for the P here or the T here. I still need to do some simplify before I make my final decision. So let's put this 10 with this 20. And if I move it over and yeah, I'm going to do that even though it's still going to be a negative. I'm going to add the 10 to this side. So T equals 2P minus 10 is what's left. So we're done with that equation. We've rearranged it to this one. These are now my 2 equations. Oh, nope. These 5 and 15 needs to go together. So again, T equals minus 5. That's going to be, and I'm just going to line the P's up, so I'm not really moving it, so it still stays a positive, and then 15 minus 5 is 10. Since I have both of these already isolated as a Thomas, that's an easy substitution. Let's go ahead and do that. So we're going to write 2P minus 10 equals P plus 10. It's just, instead of writing the T's, I'm writing these 2 concepts set equal to each other. Now let's put our P's together. Minus a P, 2 minus 1 is 1. Add a 10 to this side equals 20. So Patricia should be 20 years old. Now we need to know Thomas. So let's put him back into this equation. Looks like the easiest one. So Thomas is 20 instead of the P plus 10. So Thomas is 30 years old. I'm trying to find their actual answers to check that. Yes, okay, so Thomas's age now is 30 years old, and because this is a word problem, I definitely want to put some words with it as its label. And it does, in the question, ask how old are both people, so I do need Patricia is 20 years old as one answer, and Thomas is 30 years old for the other. Okay, now part B is the rate problems. So I'm just going to jump to example 2 so that you see how, and of course rate is a comparison. So we have Joe Frank can wash 3 cars in 5 hours. So the rate, and because I know I'm dealing with 2 different people, I'm going to do a little J here to clarify this is the rate for Joe Frank. And I will then, in the next part, it talks about Merle, so I will have a rate for Merle, so I know where I'm headed. All right, so in general, your formula would be the rate times however many jobs time. The rate times how long they work tells you how many jobs they get accomplished. So if I'm solving for just the R, I'm going to do jobs divided by time, and that's what I'm going to use here. So how many jobs did he do? 3 cars, numerator, dividing by the time in 5 hours. So there's his rate. Merle can wash 4 cars in 3 hours, so I want the same thing. The jobs divided by the time, 4 cars in 3 hours. Now I know both of their rates individually. 15 cars need to be washed. Okay, brand new equation, filling in here, rate times time equals jobs. So my jobs is the equal part. 15 is how many total need to get accomplished. If Joe Frank works for 2 hours and then is joined by Merle, how long will they have to work together to finish washing all 15 cars? Now, there's a lot of information in that sentence. I'm going to start with just the first part. If Joe Frank works for 2 hours, so his rate at 3/5 for a time of 2 hours tells me that he has accomplished 6/5 of a car being washed. So 1 1/5, if you want to think of it that way, is how much he just got done. After that 2 hours, he's joined by Merle. So in the rate of this one where I'm trying to get all 15 done, they are going to be working together at their rates 4, and it asks for how much time, but it said to finish the 15 cars. How much did already get done? The 6/5. So we need to minus the 6/5 from this so we know how much time it's going to take for them to finish all of the cars. So common denominator is necessary to add fractions. Let's make that 15. So this multiplies by 3 and turns into 9. This turns to 15, multiplies by 5. 4 times 5 is 20. 9 plus the 20 is 29/15 with the t, equals common denominator again of 5, multiplied by 5, 75. Yes, and then 75 minus 6, 69/5. Solving for time, this is multiplying. So to remove this fraction, we're going to divide. To divide a fraction, we flip and multiply. 15/29. Time equals, reducing, 5 goes in here once, 5 goes in here 3 times. So let's see, 3 times 9, 27, 18, 90, 207/29. I hope that I didn't make a mathematical error there. I'm looking for their answer. Yes, 207/29. Okay, and then we need a label. Time is, for this example, it was in hours. So it will take them 207/29 hours to finish accomplishing the cars. Let's look at example 3. Meha could empty 2 bottles in 3 hours. So the rate for probably Maya is, again, jobs divided by time. Empty 2 bottles, 3 hours. 2 bottles is the job, 3 hours is the time. Working with Wilbur, she found that they could empty. So working together, her rate of 2/3 plus the rate of Wilbur, which we don't know is the rate, and they will work for 3 hours, and they will finish 4 bottles being washed. And they want us to find how fast can Wilbur do if he is working on his own. We're going to divide by the 3 to remove it to the other side. 2/3 plus the rate of Wilbur equals 4/3 because we divided it. To get the rate alone, we're going to minus 2/3 to this side. They already have a common denominator. 4 minus 2 is 2. So we get that Wilbur's rate is 2/3. And it says for the question again, what was Wilbur's rate of emptying bottles? And my label will be 2/3 bottles per hour. Can be written this way, or you could write it as a fraction either way. you found Wilbur's rate. Example 4. 5 workers, oh, this one adds a piece. 5 workers can do one job in 8 days. Okay, so we need rate, time, people equals job. So we've added this people part here. So in each of the other examples, the people part has been just one individual person being talked about. Not to be confused with when they're working together. Yes, they form 2 people, but you don't want to use that in the equation. When they give you an amount of people, that's when you want to use this equation. So 5 workers, people, can do one job in 8 days time, and I don't know the rate. How many workers would it take? So I know I need to solve for the rate here before I move on. Rate equals 8 times 5, and that's going to divide, so 1 over 40. Yes, that's right. Okay, and then I can use that into the same equation. Rate is 1/40. How many workers would it take? So I don't know the workers, that's my unknown, to do 3 jobs in 7 days. That's my time. So now I know I'm solving for workers, and we need to multiply here. This is going to be 7/40 W equals 3, and divide to separate from what it's doing here, which is multiply, which means flip and multiply. Implied 3 over 1 times 40 over 7. Nothing I see that I can reduce, so this is 120 over 7. And then for some reason on this one, they decided to change it from its fractional format into decimal and write it as 17.14 workers, but you can just say 120 over 7 workers, same thing. That is how many workers it's going to take to accomplish those jobs. Example 5, last one in this lesson, says Mary has 252 gallons of milk. This would feed 42 infants for 12 days. Rate, time, people, jobs. Don't know my rate. It says 252 gallons of milk. That's going to be my jobs. Feeding 42 infants, people, for 12 days time. Again, I can solve for my rate. 252 divided by the 12 times 42. Calculator for that would be extremely helpful. So it looks like that actually reduces down to a half. Okay. So in my new equation, repeating the same formula, 14 more infants were placed in the nursery. So how many did I have before? 42, and I'm adding 14 more were placed in the nursery, and 48 more gallons were provided. So that's going to equal the 252 plus 42 more gallons. Make sure you can actually see that. And how long would the milk last? Now I need to know my time. So 1/2 with my t, 56 equals 294. I think that's right. Okay, then I'm going to basically make that 56 over 2t equals 294. Flip and multiply, implied 1 here, 2 over the 56, and that will definitely reduce 1 and 28. I'm not sure if 28 goes into 294. As I'm checking here, did I miscalculate time? 42 and 14, 252 and, oh, it was 48. Ha ha ha. Okay, so then 8, 9, 10, this should be 300. Okay, this should be 300. Now, can I reduce anything there? 28 and 300 will definitely go down by 2. That goes to 14 and 150. So 150 over 14. They didn't reduce it down that way. They took it again to decimal, and it's time, and the original question was for days. I'm going to leave it that way.